Hello everyone. I hope you all are doing good. We are back here today again with the module on the chapter in class 10th, that is refraction of light. In class 10th, refraction of light is being covered in two chapters. One containing refraction of light through plane surfaces and the second containing refraction of light through spherical surfaces. Let's begin with the module. Refraction of light, class 10th, lesson 1. So these two chapters, refraction of light through plane surfaces and refraction of light through spherical surfaces, have been divided into 6 lessons, where we'll be covering the topics, the concept of refraction of light through plane surfaces and spherical surfaces, concept of refractive index, refraction through glass slab and lateral displacement, refraction through glass prism and its applications, the concept of real and apparent depth, explanation of critical angle, total internal reflection and its conditions, the diagrammatical explanation of total reflecting prisms, the comparison of the image formed by total internal reflection and reflection through plane mirrors, concept of lenses, its types, terms related, ray diagrams and applications, the lens formula, sign conventions and numerical problems on it, and the understanding of the power of a lens. So let's start with the module. Refraction of light. What is refraction of light? Refraction of light is an optical phenomena. It's an optical phenomena where the light, when traveling from one optical medium to another, deviates from its original path. When we say it deviates from its original path, we mean that it changes its direction. It can slow down, it can speed up, depending upon the density of the optical medium it is entering. The cause of refraction of light is that the speed of light is different in different media. In air, we know that the speed of light is 3 into 10 raised to the power 8 meter per second, which is maximum. As the light enters different media, say glass or water, its speed changes. And as its speed changes, its path changes, and hence refraction occurs. We need to know that whenever a ray of light is incident on an interface, as you can see in this diagram, the interface is of air and water, certain portion of light gets refracted and a certain portion gets reflected. We need to understand here that the portion of light which gets reflected is very less than the portion of light which gets refracted. The bottom line is that 100% ray does not get refracted. Some part gets reflected back in the same medium, which we call as partial reflection. Now, these are the two cases where we see a ray of light traveling from denser to rarer medium and rarer to denser medium. If we see the case 1 where the ray of light travels from denser to rarer medium, we can see that the refracted ray shown in green color moves away from the normal. Whereas in case of the second picture, the ray of light when moving from rarer to denser medium moves towards the normal. So this is clear that when a ray is traveling from denser to rarer medium, its speed increases and hence it moves away from the normal. Whereas when it travels from rarer to denser medium, its speed decreases and it moves towards the normal. The laws of refraction. There are two laws of refraction which every ray follows. The first one, the incident ray, refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. The second law is the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. This law is also known as Snell's law, and the constant is known as refractive index. So from here, we get to know about the refractive index of a medium. Refractive index of a medium can also be defined as the ratio of the speed of light in vacuum or air and the speed of light in another medium. If the refractive index of a medium is represented by n and sometimes with mu, then the formula is speed of light in air or vacuum divided by speed of light in a medium is equal to refractive index of the medium. The refractive index is always of that medium where the refracted ray reaches. And whenever refractive index is with respect to air, it is known as absolute refractive index. So if we say refractive index of glass is 1.5, that means it is absolute refractive index and it is with respect to air. Now, if the ray of light is passing from medium 1 to medium 2, then the speed of light in medium 1 to speed of light in medium 2 is equal to refractive index of medium 2 with respect to refractive index of medium 1. So these are different formulae to calculate the refractive index of different media. Conditions for no deviation of ray of light. When angle of incidence is 0, that means when the ray of light strikes the surface normally, it will make an angle of incidence equal to 0 degree. And in that case, there is no deviation in the ray of light. Second, when the refractive index of two media is same. In that case, it's also, there is no deviation in the path of ray of light. The factors which change on refraction are speed, direction, and wavelength of light. Speed of light changes with change in a medium. If it passes from a denser to a rarer medium, its speed increases. And if it passes from a rarer to denser, the speed decreases. Now, as speed changes, the direction also changes. And further, the change is also seen in the wavelength of light. If the speed of the light is more, the wavelength is also more. And if the speed of the light is less, the wavelength is also less. But we need to remember over here, the frequency of light does not change with the change in the medium. Why? Because it depends on the source from where the light is coming and not on the medium. So from here we get to another relation, that if a ray of light is traveling from air to a medium, then for air we know that speed is equal to frequency into wavelength, and for the medium the speed of course will change to v, frequency remaining same remains f, and wavelength changes to lambda dash. Refractive index is equal to speed of light in air to speed of light in another medium. Putting the values, we get that refractive index is equal to lambda upon lambda dash. That means refractive index can also be calculated using the change in the wavelength of light. Factors affecting refractive index of a medium. The nature of the medium. Smaller the speed of light in a medium, higher is the refractive index. Physical conditions such as temperature. With increase in temperature, the speed of light increases. Hence, the refractive index decreases. Wavelength or color of light. In air, we know that all colors travel with same speed. But in a transparent medium, the wavelength changes. Red color has maximum wavelength, that means it has maximum speed. So, its refractive index will be minimum. Similarly, violet color has least wavelength, so that means its speed is least and hence the refractive index is maximum. Did you know, children, that the speed of light in air is 3 into 10 raised to power 8 meter per second, in glass 2 into 10 raised to power 8 meter per second, and in water 2.5 into 10 raised to power 8 meter per second. The refractive index of air is 1, that of glass is 1.5, and of water 1.33. All these refractive indices are the absolute refractive indices. Then lateral displacement is what? Lateral displacement, children, is the displacement or the perpendicular distance between the original path of incident ray and the emergent ray. Lateral displacement depends upon the angle of incidence, the thickness of glass slab, and the refractive index. It is directly proportional to all the three. That is, if these three increase, or any one of them even increases, lateral displacement also increases. So this was it in this module. Let's have a quick testing time. What do you mean by refraction of light? Second, if the refractive index of two media are same, there will be maximum deviation. What do you think? True or false? Third, state Snell's law. Fourth, out of the following, what does not change for a ray of light? Options: wavelength, direction, frequency, speed. Then last, which color of light has maximum refractive index? Do figure out the questions and get back to me with your solutions. Thank you. Have a nice day.